Hey, so I got the question. We have all these different methods for solving quadratics, and how do you know which one to use when? So that's actually a really kind of longish answer. So I have about 5 examples here to try to show you all the different things that can come up. So we have 3 methods. We have factoring, we have completing the square, which is these steps right here. That's the thing where we take half the middle term, add to both sides, and then square and do the root. And then we have the quadratic formula. So those are kind of our 3 possible ways of approaching a problem. And depending on the problem, I would use, it depends what I'm looking at, which one I'm going to pick. So if you have something pretty easy, like this one right here, so it leads with a 1. Anything leading with a 1 is going to be easier than something not leading with a 1 most of the time. And our basic thing, what we try to do here is we go, so is there anything that multiplies to be the end and adds to be the middle? And if you can figure that out pretty easily, then factoring's the way to go. So for instance, this one, what multiplies to be 45 and adds to be negative 14? Cool, 5 and 9, that's super straightforward. So I do x minus 5, x minus 9, and then there's my 2 solutions. I have another one down here that looks like this, right? It's a plain x squared, with some stuff. But what multiplies to be 45 and adds to be negative 14 is pretty easy. What multiplies to be negative 1,311 and adds to be negative 34 is really hard. I have no idea what that is. I just made this up and worked backwards to get this. But so it would take me a minute to figure out that 23 and 57. So this is one, again, it looks like that, it factors, but that might not have been the easiest way to go. So this is an example of where I might put it in the quadratic formula. My second example is one where it doesn't lead with a 1, so what that means is the factoring is harder. And I'll show you one version of that factoring. There's a lot of different flavors to how you can factor this. This is just the one that I prefer. It's called magic method. It has a similar step where here we do what multiplies to 45 adds to be negative 14. So here we go, 6 times negative 15 to get negative 90. And then we say what multiplies to negative 90 and adds to be that little invisible 1 there in the middle, which would have been a 10 and a negative 9. You could do AC method from here as well. Magic method, we bring down the 6. We duplicate it knowing that we're going to reduce it at that same step. What that means is we don't have to care about where we put these numbers. Everything's going to reduce out to the right spot. So I just do 6x, 6x, and then I need to reduce 6 somewhere, so I can reduce out 2 right here in both these factors and 3 right here, and then everything drops out in the right spot, and solve these little factors and get those 2 zeros. So that, most people are not that good at factoring, that this one is a stretch for them. So what might be better in that situation, if you don't actually need a factor, if you just need those numbers, that might not be the worst one to throw into the quadratic. Even though it does factor, it really depends on your level of comfort with factoring. So, and then I'll say something at the end where I encourage you to be comfortable with factoring. So if I throw it in the quadratic, very straightforward, very plug and chug. We just, the 6, the 1, and the negative 15, there they all are. I toss them in. Right here, when you get the square root of 361, that comes out to a nice perfect square, so that meant that would have factored. And then here's where I'm just doing my negative 1 plus the 19 and negative 1 minus the 19, and we get the exact same answer. So here, neither one of those is terribly easy, but whichever is the easiest for you is the way to go. This next example, so here if we tried our what multiplies to be the end, and remember this looks a lot like this, it's an x squared with a couple of terms, but here if we try what multiplies to be 1 and adds to be negative 12, there is no numbers that multiply to be 1 and add to be negative 12. So now I know I need to either complete the square or quadratic formula, because that's not going to factor. And so here I did out the quadratic formula, and I won't talk through all the steps of it. Something I don't like about this is there's a bit of room here to get stuff wrong, and it's this step right here where students have trouble. So when we got to this 140, if a 4 goes in there, or anything that might reduce, I would need to reduce this radical. In this case, it was a 4 times 35. So I bring out that 4 as this 2, and then you have to be careful to get that reduced properly. So this 2 belongs to both terms, so this would be a 6, and then that reduces to the invisible 1. So if you have a quadratic where a is 1 and b is an even number, The math is easier if you complete the square. That said, I'm pretty good at both methods, so for me, I would do this one. Some students would go ahead and keep using the quadratic. But let me just remind you, completing the square down here. So that's where we bring the 1 over. And again, if this is even, it's going to be great because then we go half of 12 is 6 and we don't get a fraction. If it's odd, it's terrible. You get a fraction, do quadratic formula. But here, half of 12 is 6. Squared makes 36. I add that to both sides. I factor here. This makes the 35. I root both sides. And then there I am at the answer without all this really crappy reducing that we had to do back here. So there's one reason to have both of those tools in your toolbox, is because I got to do a lot easier math because I'm good at completing the square. That said, quadratic formula gets it done. And then here's my other reason why you need all three methods, because sometimes you're not using it to solve a quadratic, sometimes you're using that method to do something else. So simply reducing a fraction in algebra, the way that you do that is you factor and then you cancel. And if you don't know how to factor, or if you've just shoved everything in the quadratic, you're really bad at this kind of basic algebra then. So here we just do multiplies 16, adds to 10, 2 and 8. X squared minus 4, that's our a squared minus b squared, so a plus b, a minus b. And you see I have those common factors, so that would be me reducing a fraction. Likewise, when we get to the conic section, in terms of completing the square, this is an equation of a circle. This is standard form for a circle. This is a circle, it's just not in standard form yet. And the way that you get from here down to standard form is you complete the square twice. And we'll see that with our second round with parabolas, ellipses, and hyperbola as well. So we're not using completing the square to solve, we're using it to get it into a particular form that is more convenient to work with. So there's an example of factoring and completing the square. So even though you can solve everything with the quadratic formula, if it's quadratic, it's not always the best tool for the job, and there's other jobs that have to get done as well. So I'd encourage you to get good at all three methods if you have a lot of math to take. Cool, hopefully that was helpful.